Yum, yum!
William Vaughn here with a quick introduction to using linear and radial falloffs in MODO. The effect any tool has on a selected region of geometry is rigid, meaning applications of the tool happen at a constant rate across the selected range. Simply put, components are either selected or not selected. If nothing is selected, then all elements in the active meshes are considered selected. We can use falloffs to provide a way to attenuate the effect a tool has over a selection. Falloffs enable you to gradually decrease the intensity of a tool across a defined range. You can access the various falloff types by using the falloff drop-down menu located above the 3D viewport or from the Edit menu under Falloff. The easiest way to explain falloffs is to see them in action. One of the most common falloff types is linear. Once active, the falloff properties are visible in the Tool's Properties panel as an adjunct to the tool's properties. Each falloff has its own specific settings that you'll want to get familiar with to be able to take full advantage of the falloffs. To define the range of the linear falloff, simply right-click and drag in the viewport. The linear falloff uses a straight line to define the falloff. The line itself determines the direction of the falloff's influence and the strength of the effect itself. All of the vertices at one end of the line receive 100% of the tool's influence, and the vertices at the other side receive 0% of the tool's influence. The points between the two lines receive some partial value based on the interpolation between the two endpoints. You can quickly reverse the influence of the falloff by using the reverse option. The symmetric options enable you to mirror the influence area of the falloff. You can also change the shape of the falloff by taking advantage of the shape presets, which are similar to modifying the interpolation of one key to another in the graph editor. Several tools you might already use take advantage of linear falloff. The Shear Tool, for example, is simply the Move tool with linear falloff. The Twist tool uses Axis Rotate with linear falloff and in the automatic type for its action center. The Taper tool uses Scale with the linear falloff, and the Flare tool uses linear falloff as well. Using any of these tools should help to gain a better understanding of not only how useful linear falloff is, but how it can be used to speed up the modeling process. Another common falloff is radial falloff, which uses a sphere where all vertices at the center of the sphere receive 100% tool influence, and any vertices outside the sphere receive 0% of the tool's influence. Just like the linear falloff, you can change the interpolation style by using the shape preset attribute. If you've ever used Soft Move, you've simply used the Move tool with Radial Falloff. Swirl uses Radial Falloff combined with Axis Rotate and the automatic action center type. And the Bulge tool uses the Scale tool with Radial Falloff to produce a swelling effect. Explore these tools or combine Radial Falloff with other tools to expand your ability to manipulate your meshes with more control. Oh, look at the time.